All right, I'll say it. So my students say that I'm supposed to say, please press like and subscribe.
Like and subscribe.
Shout out to Liz, but you guys are weird. So let me hold on, be quiet, you guys. We've got serious work to do. So I want to talk about significant digits. Okay, significant digits are important when you're rounding things when it comes to precision and accuracy. Okay, pay attention. Look at the screen. There's a process for this, and so I'm going to go through, and then I'll tell you my little shortcut that helps me remember. So, all non-zero digits are significant. So what that means is as I look at this, this has 1, 2, 3, 4 non-zeros. So that has 4 significant figures. This has 1, 2, 3 non-zero numbers, so it has 3 significant figures. See how that works?
Yeah.
Zeros, let's do a different color. Zeros between 2 significant figures are also significant. So I have a 0 here, right? So that's important because it's between 2 non-zeros. So zeros between 2 significant figures, right? So if I go like this, oops. I highlighted. I can't highlight more. If they're between 2 significant figures, right? So it's between 2 significant figures. The 1 is significant because it's non-zero. This is non-zero. So I've got 1, 2, 3. So I have 3 significant figures. This is significant because that's a non-zero. This is significant. How many numbers are there in between the 2 numbers? Well, there's 1, 2, 3, 4, 5, 6, 7. So I have 7 significant digits. Okay. Let's do some more. Zeros at the end or the right of the decimals are significant. This has to do with precision. So guys, I'm writing a lot of stuff down. I don't see pencils in your hand.
There is a pencil.
Well, you're not writing stuff down. Significant figures has to do with precision. Why would somebody write down 3.9000 when it's the same as 3.9?
I don't know.
I'm telling you why, because they measured this far. They want you to know that we measured it out to the thousandth spot. Right?
Yeah.
Okay. So, what does that mean? Well, anything to the right of the decimal point is important. So, this is a non-zero, so it's significant. This is a non-zero, that's significant. This is a 0 to the right, significant, 0 to the right. How many significant digits? 4. Non-zero, 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 0 on the right of the decimal point, 4 significant digits. Zeros to the left are not significant. So we don't care about this. We don't care about this. We don't care about this. Oh, wait, is that to the right? Oh, I mean, I got to slow down. Okay. So, wait a second. Wait. Let's read this again. Zeros to the left of the first non-zero digit in the decimal are not significant. So they're saying that this has 2 significant figures because this is a non-zero, this is a non-zero. They're saying that this has 3 significant figures because all 3 of those are. This is a non-zero, but I have a 0 in between another non-zero, so you count all 3. Zeros at the end of the number without a decimal point are not significant. So I have a non-zero, a 0, and a non-zero. that's only 3 significants. I have 1, 2, and the rest are zeros, so only 2 of those are significant. So the only zeros that matter are the ones to the right of the decimal place or zeros that are trapped between 2 non-zeros. Does that make sense?
Yeah.
So let's try to figure out what the significance, the number of significant figures I got some problems here we're going to do. So non-zero digits, I've got 1, 2, 3, right? How many they're saying significant digits, right? So this is the number they give us, and we're going to think out loud. So I've got 1, 2, 3. There's 3 of them. Zeros between 2 significant digits. So this is trapped between a significant, this is trapped between a significant, this is trapped, this is trapped. So I have 4 trapped between them. Any zeros at the end of the right of the decimal? Yeah, one more. 3 plus 4 plus 7 is 8. So if I look at this, I've got 1, 2, 3, 4, 5, 6, 7, 8 significant figures. So this whole thing has 7 significant figures. Okay, now let's do one on our own. How many non-zeros? Well, I see 1, 2, 3, right? How many zeros that are trapped between 2 significant digits?
2.
There's this one and this one. Yep, that's 2. How many zeros to the right of the decimal? Just 1. What's 3 plus 2 plus 1? 6. So this has 6 significant digits. So on the previous problem, remember when I said the problem, I said we're going to round to this and we're going to round to that, and why we're rounding? That has to do with significant figures. Okay? Does anybody have any questions on that?